Hello everyone. Let us continue with the part 2 of Polytechnic lecturer Electronics Engineering 2021 question paper conducted by Kerala Public Service Commission. 51st question. The main purpose of instrumentation amplifier is to amplify the small signals that are riding on large common mode voltages. The correct option is B. This instrumentation amplifier is a device that amplifies the difference between two signal voltages while rejecting any signals that are common to both inputs. So this is a circuit diagram given for the instrumentation amplifier. In this circuit diagram, there are three amplifiers. Amplifier 1 and amplifier 2 are non-inverting amplifiers. 1 and 2 are non-inverting amplifiers, and amplifier 3 is a difference amplifier. These three amplifiers, these three operational amplifiers together form an instrumentation amplifier. So this instrumentation amplifier overall gain is this is the overall gain R3 by R2. So this is resistor R3 by R2 into 1 plus 2R1 by R gain into V1 minus V2. So V1 minus V2. This is the overall gain of instrumentation amplifier. The gain of three op amp instrumentational amplifier circuit depends on resistor gains. So here the voltage gain V out depends on RG in. So that means the gain of amplifier depends on external resistors. Similarly, for an instrumentation amplifier, it should have high gain accuracy, high common mode rejection ratio, high stability with low temperature coefficient, low DC offset, and low output impedance. These are the features of instrumentation amplifier. An instrumentation amplifier is used to amplify very low level signals, rejecting noise and interference. So correct option is B. Next question. The filter which provides roll off greater than minus 20 dB per decade per pole and are useful when rapid roll off required is Chebyshev filter, because the transition bandwidth is more in Butterworth filter when compared to the Chebyshev filter. So from this graph, see the transition roll off. So for Butterworth filter, transition roll off is not sharp, but whereas for Chebyshev filter, transition roll off is very faster, very steeper. And this for Chebyshev filter, there are ripples in pass band or ripples in stop band depending upon the type of filter. The magnitude response of Butterworth filter decreases monotonically as frequency increases, whereas magnitude response of Chebyshev filter exhibit ripples in pass band or stop band based on the type of filter. If it is type 1 filter, it shows ripples in pass band. If it is type 2 filter, it exhibits ripples in stop band. For same specifications, the number of poles in Butterworth filter are more when compared to the Chebyshev filter. That is, the order of Chebyshev filter is less than the order of Butterworth filter. The poles of Butterworth filter lie on a circle, whereas the poles of Chebyshev filter lie on ellipse. The transition bandwidth is more in Butterworth filter. So this is the transition bandwidth. It is more for Butterworth filter where compared to Chebyshev filter. The transition bandwidth is very faster. Here it is slower. So correct option is B. Next question. 555 timer basically consists of. So functional diagram of 555 timer is shown in this figure. So in this functional diagram, 555 timer consists of three 5 kilo ohm resistors, which are connected in series between supply voltage VCC and ground, and it consists of two comparators, upper comparator and lower comparator. So two comparators, upper comparator, lower comparator. It consists of three 5 kilo ohm resistors connected between VCC and ground, flip-flop and transistor as well as inverter circuit. So transistors and inverters, flip-flops, two comparators, voltage divider network. These are the components of 555 timer. So correct option is it consists of two comparators. So the definition of 555 timer is it is highly stable device for generating accurate time delays or oscillations. The- if we combine two 555 timers, then it will form 556 timer. A single 555 timer can provide time delay ranging from microseconds to hours, and various applications of this 555 timer includes oscillator, pulse generator, ramp and square wave generator, monoshot multivibrator, traffic light control, and voltage monitor, etc. These are the different applications of 555 timer. But the question is, it consists of two comparators. This from the functional block diagram, it consists of voltage divider, two comparators, flip-flops, SR flip-flop, transistors and inverters. Next question. The output voltage of phase detector is. So this is a circuit diagram for phase lock loop. In this phase lock loop circuit diagram, so phase detector is a component. The output voltage of phase detector or phase mixer or comparator in a phase lock loop is DC voltage that is proportional to the difference between two inputs known as error voltage. Correct option is C. The output of this phase detector is error voltage VE, that is DC voltage error voltage. If an input signal Vs of frequency Fs is applied to PLL, that is phase lock loop, the phase detector compares the phase and frequency of incoming signal to that of output voltage V0 and F0 of voltage controlled oscillator. So this phase detector compares this incoming signal Vs of frequency Fs with V0 and Fs and produces an error voltage which is a DC voltage. If these two signals differ in frequency or phase, an error voltage VE is generated. So the function of phase detector is it generates a error voltage. The output voltage of phase detector is DC voltage known as error voltage. Then it is applied to low pass filter. This error voltage is applied to low pass filter which removes the high frequency noise and produces the DC level. Correct option is C. Next question. In a linear op amp circuit, in a non-linear op amp circuit, what is the condition of it? So it never saturates. So generally non-linear op amp circuits, it goes into saturation. So linear operational amplifier circuit, the op amp does not go into saturation. So non-linear means it goes into saturation. So option A is wrong. The output of linear op amp circuit has same shape as the input signal. So same shape as input signal. So this option C is also wrong. So option A for linear amplifier, option C for linear amplifier. But in the question they have given non-linear amplifier circuit. Next, feedback loop is never opened. In linear operational amplifier circuit, feedback loop is never opened. These three statements are related to linear operational amplifier, but option 4 it is related to nonlinear amplifier. It may saturate. A nonlinear operational amplifier circuit works in switching mode, that is nonlinear mode operation occurs when op amp reaches to either positive saturation or negative saturation. Nonlinear op amp circuit has no feedback, only open loop exists. The first three statements are related to linear operational amplifier circuit, and statement 4 is related to non-linear. Okay. So correct option is D. Non-linear op amp circuit doesn't enter into non-linear operational amplifier circuit may saturate because it's working in switching mode. Schmitt trigger has. So Schmitt trigger is a regenerative comparator, also known as Schmitt trigger. It is a comparator circuit with positive feedback. There are no compensating capacitors in Schmitt trigger, no pull-up resistors, and negative feedback doesn't exist in Schmitt trigger. So no compensating resistors in Schmitt trigger circuit, no pull-up resistors, and there is no negative feedback. So these are the circuit diagrams for non-inverting Schmitt trigger circuit and inverting Schmitt trigger circuit. In case of non-inverting Schmitt trigger circuit, input voltage is applied to non-inverting input terminal of operational amplifier. In inverting Smith trigger circuit, input is applied to inverting input terminal of operational amplifier. So this Smith trigger exhibit a phenomenon called hysteresis or backlash. Okay. When the input is given to non-inverting input terminal of op-amp and positive feedback is applied from output to input, it is known as non-inverting Smith trigger. So similarly, for inverting Smith trigger, the input is applied to inverting terminal of op-amp and positive feedback. So the feedback is positive. Whether it is inverting or non-inverting, the feedback is positive. The positive feedback is applied from output to input, known as inverting Smith trigger. So correct option is A. Next question. In a phase locked loop, in a locked state of PLL, the phase error between input and output is, so the phase error between input and output is 0 or minimum. It is constant value which is 0 or minimum. Ideal case it is 0 because in a locked state it is 0. PLL, this phase locked loop reduces the circuit diagram of PLL. In a locked condition, there is a zero phase difference or a constant phase difference between the two signals, that is Vs and V0. Between these two signals in a locked state, the phase difference between the signals is 0. PLL is said to be in a locked state when output signal frequency and phase, but when output signal frequency and phase matches with the match the input signal frequency and phase. Hence, phase difference between the signals is 0 or constant. PLL reduces the error between output and input signals. When the phase difference between these two signals is 0, the system is said to be in locked state. So that is correct option is minimum. In locked state, it is minimum as per the options, but ideally it is 0. Next question. For an integrating circuit to be effective, the RC product should be dash the time period of input wave. If the time constant of RC low pass filter is very large in comparison with the time required for an input signal to make an appreciable change, then the circuit acts as an integrator. Circuit acts as an integrator provided the RC time constant of circuit is greater than 15 times of time period of input signal. A RC low pass filter with very large time constant, it acts as integrator, and RC high pass filter with very small time constant, it acts as differentiator. Similarly, if the time constant of RC high pass filter circuit is very small, in comparison with the time required for input signal to make an appreciable change, then the circuit acts as a differentiator provided the time period of input signal is greater than 15 times of time constant. So correct option is at least 10 times. So as per this, at least 10 times is the correct option. Next question. The decimal equivalent of 11011.01 base 2 is. So multiply. So how to find the decimal equivalent for the given binary number is multiply each digit separately from the left hand side of radix point till first digit by 2 power 0, 2 power 1, 2 power 2 respectively, and divide each digit on the right hand side of the radix point. So left side of radix points digits are multiplied with their weights. Similarly, right side of the radix point digits are multiplied with divided with their corresponding weights. To convert binary to decimal, multiply each digit in the binary number by 2 raised power of its position. So that is multiply each digit in the binary number by 2 raised power of its position and then add the result together. We will get from binary to decimal conversion. This is a procedure for converting binary signal to decimal signal. So given binary number is 11011.01 base 2. So this is a radix point. So on the left hand side of the radix point, multiply each digit by 2 power of its position. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. So after it is divided by, so 1 by 2 power 0, that is 2 power minus 1, 2 power minus 2. Now equivalent is 16 plus 8, 16 plus 8 plus 0 plus 2 plus 1, 0 plus 1 by 4, 1 by 4. So 24, 26, 27, 27.25 base 10. So the correct option is 27.25 base 10. Oh, 27.25 base 10. Correct option is C. Next question. The device which converts BCD to 7 segment, it is called decoder. So decoder is a device. The correct option is B. The decoder is a device which converts BCD to 7 segment. BCD to 7 segment decoder has 4 input lines A, B, C, D and 7 output lines A, B, C, D, E, F, G as shown in the figure. This is a decoder circuit with 4 input lines A, B, C, D and 7 output lines small a to small g, and these lines are given to LED positions. The output is given to 7 segment LED display which displays the decimal number depending on inputs. Decoder is an multiple input, multiple output combinational logic circuit which converts coded inputs to coded output. There is one to one mapping from input code to output code. So the decoder is said to be binary decoder if it has n input lines with n input lines and 2 power n output lines. If there are n input lines and 2 power n output lines, then this decoder is said to be binary decoder. Otherwise, general definition is decoder is a multiple input, multiple output combinational logic circuit that converts coded inputs to coded outputs. So as per the question, so BCD to 7 segment display converter is decoder. Next question. The specification of the simplification of Boolean algebra. The expression is given. We need to simplify the given expression. So we know that from the laws of Boolean algebra, 1 plus x is 1, x plus x bar is 1. Also the De Morgan's law. So De Morgan's law is a plus b bar is equal to a bar plus a bar b bar, and ab whole bar is a bar plus b bar. That is sum of complement is product of individual complements. Complement of product is sum of complement of individual terms. Let us apply this De Morgan's law as well as these two laws of Boolean algebra. Boolean algebra. Given expression is a bar b c bar whole bar plus a b bar c whole bar. So apply De Morgan's law. So that is a bar whole bar plus b bar plus c bar whole bar plus a bar b bar whole bar plus c bar. So it will become a bar whole bar is 2 times of complement is variable itself, complementing the variable with 2 times a bar whole bar, or a complement whole complement is variable itself, that is a plus b bar plus c plus a bar plus b plus c bar. Now a bar a plus a bar is can be rearranged as a plus a bar a plus a bar plus b plus b bar plus c plus c bar. So x plus x bar is 1. So that is 1 plus 1 plus 1. So in one Boolean algebra, 1 plus something. So 1 plus something, its value is 1 only. So the correct option is B. Next question. SOP of given expression is, so sum of products form of given expression. Given expression is a plus c ab bar plus ac a bar c bar plus b bar. So this is a given expression. So this expression can be written as this one. So p plus xy is equal to p plus x, p plus y, that is a plus c. Take a common in the from the second term, take a common, so a common, so it will become b bar plus c, and this expression will become p plus x, that is b bar plus a bar, b bar plus c bar. Now next is a plus c, multiply these two expressions, so multiply these two, so that is b bar plus c, b bar plus c bar. So b bar into b bar, a into a is variable itself, so b bar into b bar is b plus b bar into c, b bar c bar, again b bar c plus c c bar, so c c bar is 0. Take b bar common, so if b bar is common, 1 plus c bar plus c, so 1 plus something, so its value is b bar. Next it is a b bar plus a bar into b bar. Now it will become a b bar multiply a plus c, a bar plus b bar, so a plus c, a bar, a b bar, c a bar, c b bar. A bar is 0, so it is 0. Now the expression become a b bar into a b bar, that is a b bar plus a b bar into a bar c plus a b bar into c b bar. So here it is a bar, a bar is 0, the expression is a b bar plus a b bar c, a b bar plus a b bar c. The correct option is a b bar plus a b bar c is the correct option. A into a is 1, or b bar into b bar is b, it's b only, a into a is a. So using these simple rules of Boolean algebra, we will try to we will solve this expression. Next question: data can be changed from spatial code to temporal code. So it can be done by using shift registers. Analog to digital converter means the purpose of this analog to digital converter is to convert analog signal to digital signal. And combination logic circuits, when the logic gates are connected together to produce a specified output for certain specified combinations of input variables with no storage involved, then the resulting circuit is combinational logic circuits. So examples of combinational logic circuits are encoder, decoder, multiplexer, demultiplexer, half adder, half subtractor, full adder, full subtractor, and then parallel adder. So these combinational logic circuits doesn't convert spatial code to temporal code. So shift registers are used to convert spatial code to temporal code, but this multiplexer also convert, but in the example they have given combination logic circuit, so it is wrong. A to D converter is wrong, counter is wrong, because counter means a group of flip-flops connected together to perform counting operation. Shift register is a group of flip-flops connected together to perform shifting operations. So different types of shift registers or various shift registers are parallel in, serial out, parallel in, parallel out, serial in, parallel out, serial in, serial out. These are the four categories. In the question they have given spatial code to temporal code. So the correct option is A, shift register. Next question. The gates required for building half adder circuit is. So let us see half adder circuit diagram, logic diagram. This is a logic diagram of for half adder circuit. So the half adder is a combination logic circuit that can produces with two inputs A and B and produces two outputs sum and carry. These are the inputs of half adder and outputs of half adder. So it's a combination logic circuits with two inputs A and B and two outputs sum and carry. The half adder circuit consists of OR gate and AND gate. Sum expression is equivalent to A XOR B, A XOR B, and carry is equivalent to A and B, that is AB. And truth table of half adder. So the gates required to build half adder is one XOR gate and one AND gate. So correct option is C. Similarly, for full adder, two XOR gates, two AND gates, and one OR gate is required. So full adder is a combination logic circuits with three inputs and produces the two outputs, that is sum and carry. Next question. Dash logic family has low power dissipation and dash logic family has excellent noise immunity. So low power dissipation. Low power dissipation is for CMOS or followed by MOS and then RTL. So this is a power dissipation. The sequence for power dissipation in ascending order. CMOS is having lowest. In the option there is no CMOS, and then MOS is having lower power dissipation. No option. Then it is RTL. So RTL and dash logic family has excellent noise margin HTL. HTL and RTL are the answers. So the correct option is B. So now ECL is the fastest logic family and ECL provides wired OR logic. ECL logic is also called current steering logic or current mode logic. HTL, high threshold logic, is having highest noise immunity followed by CMOS, and CMOS is having lowest power dissipation and highest fan out. This ECL provides wired OR logic. Rest TTL, TTL, DTL, RTL, these provides wired AND logic. The correct option is B. Next question. Why a pull-up resistor is needed when connecting TTL logic to CMOS gates? So this pull-up resistor is needed when connecting TTL logic to CMOS. So for connecting TTL logic to CMOS logic, we require a pull-up resistor because the TTL outputs may not reach the voltage required voltage level, voltage required for a CMOS logic high. So that pull-up resistor helps to boost the signal to meet the help to boost the signal to meet the signal of CMOS input requirements. Help to boost the signal to meet the CMOS input requirements. So this pull-up resistor pulls the signal up to necessary voltage, ensuring CMOS input interprets the signal correctly as logic high. So if there is no pull-up resistor means the signal can be the logic high in TTL may be treated as logic 0 in CMOS. So logic high in TTL should be treated as logic high in CMOS. So that means we require a pull-up resistor which boosts the voltage level. Next question. A basic SR flip-flop can be constructed by cross-coupling which of the following gates? NAND gates and NOR gates. NAND and NOR. Correct option is C. Both NAND and NOR gates are required. With the help of both NAND gate and NOR gate, we can construct a basic SR flip-flop or SR latch by cross-coupling the outputs. So this is SR latch using NOR gate and SR latch using NAND gate is given. Correct option is C. Next question. The output F of a given digital circuit is, let us assume P be the output of this XOR gate. So gate 1, this is gate 2 and this is gate 3. P will be the output of gate 1, Q will be the output of gate 2. So for inputs P, for gate 1 inputs are X and Y. So that is P is equal to X plus X XOR of X comma Y, that is X bar Y plus Y bar X. Output Q is Z, this is one input and next input is P. So Z X NOR of P, that is Z P bar plus Z bar plus P bar. Now final output is AND gate of this P and Q. Final is AND gate of P and Q. Therefore, F is equal to P dot Q. So P dot Q is P and of ZP plus Z bar P bar. So that is P into P is P, P Z, P bar, Z bar is 0. The final output is P into Z. So that is final output is Z into P. P value is X bar Y plus Y bar X. It will become X bar Y Z X Y bar Z. So correct option is A. Next question. Flash type A to D converter is also called. So there are four varieties of different types of analog to digital converters which converts analog to digital signal or parallel comparator or flash type A to D converter. So parallel comparator or flash type A to D converter. Next counter type or ramp type A to D analog to digital converter. Next is successive approximation type analog to digital converter. Then integrating type analog to digital converter. For this flash type comparator or parallel type comparator, the conversion time is 1 clock cycle. So this is conversion time. So conversion time is 1 clock cycle. Similarly, for counter type A to D converter or ramp type A to D converter, the clock cycle is 2 power n minus 1 clock cycles. The time it requires to convert an analog signal to digital signal is 2 power n minus 1. For a successive approximation type analog to digital converter, the number of clock cycles required to convert analog signal to digital signal is n clock cycles. Suppose it is n is number of bits, n bit A to D converter. For integrating type analog to digital converter, it requires 2 power n plus 1, approximately 2 power n plus 1 clock cycles. So this is the slowest converter which requires very long time, and fastest is flash comparator or a parallel comparator which takes only very 1 clock cycle, which is very fastest. So correct option is D. Next question. So in a microprocessor, the address of the next instruction to be executed is stored in program counter. So program counter is a register that stores the address of next instruction to be executed, also known as instruction pointer. This program counter is also known as instruction pointer or instruction counter or instruction address register. These are the different names. Next, address latch register in a microprocessor is a register that stores and increments or decrements the address. It is used to execute the instructions related to program counter or stack pointer. Address latch is a circuit that stores addresses into the register. So the correct option is program counter. It is not an address latch, not a temporary data register, not a general purpose register. And various general purpose registers that are used in microprocessor. These registers are used to store data temporarily within the microprocessor. There are eight general purpose registers, 16 bit of 8086 microprocessor. There are 8 general purpose registers of 16 bit size in 8086 microprocessor. Those are AX is accumulator, BX is base register, CX is counter register, DX is data register, SP stack pointer, BP base pointer, SI source index, and DI is destination index. Hence correct option is program counter. Next question. Which of the following instruction is not valid? Move ds, 500. It is an invalid instruction because both source and destination operations cannot be the memory locations. Next, move ax, bx. It moves the content of register bx to the register ax. The content is moved from register ax to register bx. Similarly, move ax, 5000h. It copies the content of address location 5000h into the ax register. This address location here register is directly mentioned. Next is push ax, pushes the content of accumulator onto the stack. Stack pointer is incremented by 2 after the execution of each instruction. So correct option is B, which is an invalid instruction. Rest 3 are valid instructions. So invalid, not valid. So this B. Next question. Computer memory, which is used to store programs and data currently being processed by the CPU, is, that is RAM. primary memory or volatile memory. So RAM, random access memory, is a computer memory that stores program and data that are currently being processed by CPU. So it is RAM. In specific, it is cache registers or register memory. So this non PROM, mass memory, non-volatile memory, these are non-volatile memory. RAM is a volatile memory. The data is lost when computer is turned off, and it is called random access because CPU can access any part of memory at any time. So correct option is RAM, that is volatile memory. Next question. A system is said to be shift invariant only if a system is said to be time invariant if output if the characteristics of system does not change with time, or a system is said to be time invariant if the response of the system to an output is not a function of time if its input output characteristics does not change with the time. This is a definition of time invariant system or shift invariant system if characteristics does not change with time. So correct option is A. A shift in input signal also results in the corresponding shift in the output. It is time invariant system or shift invariant system. One more thing is a system is said to be time invariant if output due to delayed input is equal to the delayed output. So this is the output due to the delayed input and it is delayed output. If these two are equal, then it is time invariant or shift invariant system. One is characteristics does not change with time, and the second one is the response of the system to output is not a function of time, or otherwise output due to delayed input is equal to response due to delayed output, or a shift in input signal also results in the same shift in the corresponding output signal. These are the four different definitions of shift invariant system. Next question. Atmospheric noise become less severe at. So the atmospheric noise become less severe at above 30 megahertz. So that is above 30 megahertz is very high frequencies. From these very high frequencies, the atmospheric noise will become very less. This noise is also called static noise, and it is a main source of interference for telecommunication frequencies above high frequencies. So generally, the noise is an unwanted signal. So above 30 hertz. So this is the frequencies above 30 hertz. From these frequencies, there is no atmospheric noise, but in these frequencies, atmospheric noise may exist. Here no, atmospheric noise doesn't exist. No atmospheric noise. It is less severe at frequencies above 30 megahertz, that is frequencies above from very high frequency onwards there is no atmospheric noise. Next, atmospheric, because the atmospheric, there are two reasons. One is atmospheric noise, these higher frequencies are limited to line of sight propagation around 80 kilometers of propagation distance, and the sources of atmospheric noise generated is very less in VHF and above. The different sources of atmospheric noise are thunderstorms, cloud to ground lightning, that is lightning discharges, and other natural electric disturbances in the atmosphere. Correct option is B. There is no atmospheric noise in this frequency range because the propagation of signal is limited to line of sight, and the sources of atmospheric noise in these frequencies doesn't exist, are very limited. Correct option is B. Next question. 75th question. A 2 gigahertz carrier in a DSB-SC modulator. So given modulation scheme is double sideband suppressed carrier modulation scheme. That the carrier frequency is 2 gigahertz, that is 2 into 10 power 9, that is 2000 megahertz, and message signal frequency is 1 megahertz. Now in DSB-SC signal it consists of two sidebands, that is upper sideband and lower sideband, and carrier component is suppressed in the DSB-SC signal. Let us assume this is a spectrum of message signal. Different spectral diagrams are given. So that is M of F, the spectrum of message signal M of F, and the spectrum of carrier signal C of F, and spectrum of DSB-SC signal, that is S of F. Now the spectral components consist of the spectrum of DSB-SC signal. This is DSB-SC signal spectrum. It consists of two sidebands, that is upper sideband and lower sideband, FC plus FM, FC minus FM. So that is 2000 megahertz plus 1 megahertz, 2000 megahertz minus 1 megahertz. And the minimum sampling frequency, in the question they have asked minimum sampling frequency. So that is 2 into highest frequency component of message signal. So minimum sampling frequency is now highest frequency component FC plus FM 2001 megahertz. So this is 199 megahertz, highest and lowest frequency component. Now sampling frequency Fs is 2 times of FM. So FM is highest frequency component of message signal, that is 1 megahertz, 2 into, so highest frequency is this one, 2001 megahertz, 2 into 2001 megahertz. So now sampling frequency is 4002 megahertz or 4.002 gigahertz. This is the sampling frequency for the given signal. So correct option is C. Next question. A 1 megahertz sinusoidal carrier is amplitude modulated. So given modulation is amplitude modulation. So standard amplitude modulation or conventional amplitude modulation. So for standard amplitude modulated signal, it consists of carrier frequency. In DSP-SC signal, there is no carrier frequency. Carrier is suppressed. In case of standard AM, carrier frequency exists upper sideband and lower sideband. And carrier frequency FC is 1 megahertz and message signal FM is 100 microsecond. So that is 10 kilohertz. Message signal frequency and carrier signal frequency is 10 kilohertz and 10 power 6 hertz, that is 1 megahertz. Now which of the following frequencies will not be present in the modulated signal? So these frequencies are present. So that is 10 power 6 frequency is present, 10 power 6 plus 10 kilohertz. So that is 10 power 6 is 1000 kilo plus 10 kilo, 1000 kilo minus 10 kilo. So that is what are the frequency components present is 1000 kilohertz, 1010 kilohertz and 990 kilohertz. So this is carrier frequency and this is upper sideband and this is lower sideband. Upper sideband and lower sideband. Okay. So the correct option is 990. It is present, and 1010 it is present, 1020 1030. These two are the correct options. So not present is both C and D, but as per key only option C is the correct as per the key, but 1030 frequency component is also doesn't exist. Next question. A super heterodyne receiver with intermediate frequency FIF, let us intermediate frequency is 455 kilohertz and FS incoming signal frequency is 2800 kilohertz, that is tuned to the station operating frequency 2800 kilohertz. Now what is the image frequency? So image frequency, the relation between image frequency and intermediate frequency and signal frequency is image frequency is equal to signal frequency plus 2 times of intermediate frequency. Now image frequency is F image frequency is equal to signal frequency, so that is 2800 kilohertz plus 2 times of 455 kilohertz. So that is 2 into intermediate frequency 455 kilohertz, that is 900, 2800 kilohertz plus 900 kilohertz. So that is 3710. 455 is 910. So this is 910. Correct option is 3710 kilohertz. So that is A. Next question. In BPSK signal detector, the local oscillator has a fixed phase error of 40 degrees. Then phase error deviates the signal to noise ratio or the output by a factor of cos square 40 is an option. So in BPSK, if detector has a fixed phase error of theta degrees, then output power would change by a factor of cos square theta. Output voltage would change by a factor of cos theta, and the power would change by a factor of cos square theta. Correct option is B. Compression in PCM refers to the relative compression of higher signal amplitudes. So in PCM, the compression refers to compression of higher signal amplitudes. Large magnitude compression of higher compression pulse code modulation refers to the relative compression of higher signal amplitudes. In PCM, compression refers to the use of companding, that is nonlinear quantization technique, to improve signal to noise ratio of weak signals. Compression of signal at the transmitter before quantization and expanding the signal at the receiver is to mitigate the detrimental effects of channel with limited dynamic range. And this compression is of two types. Companding is of two types, that is mu law quantizer and A law quantizer. Correct option is C. Next question. Fraunhofer field of an antenna varies with the distance. So the region surround the antenna is divided into three types. The space surrounding the antenna is divided into three regions. One is reactive near field, radiating near field. In reactive near field, only the field is reactive, that is induction field dominates, and radiating near field, that is Fresnel zone, and far field, Fraunhofer zone, where the radiation is completely dependent. The angular distribution is dependent on the distance. The angular distribution is independent in far field. So the angular distribution is independent upon the distance, whereas in radiating near field zone, the radiation field is the angular distribution is depending on the distance from the antenna. So this is reactive near field, where the field is inductive, and radiating near field, all Fresnel zone, the angular distribution is dependent on distance, and Fraunhofer far field region or Fraunhofer region, the angular distribution is independent of distance. Now this region R1, so the region between within the range 0.62 d cube by square root of d cube by lambda, it is R1 zone, and between this R2 is 2 d square by lambda. From this point to this point, it is between these two 0.62 square root of d cube by lambda region less than 2 d square by lambda. This is for radiating field near less than 2 d square by lambda. So between this region, the radiating near field or Fresnel region. So when it is greater than 2 d square by lambda, it is greater than 2 d square by lambda, that is far field region. In the far field region of antenna varies with the distance r as 1 by r. So that electric field is inversely proportional to 1 by r. So that is electric field at an angle at a distance r is inversely proportional to 1 by r in far field region. So here it is 1 by r. In radiating near field, the electric field is proportional to 1 by r square, but in near field region it is proportional to 1 by r cube. In near field it is proportional to 1 by r cube. So the correct option is A, that is 1 by r. So the space or surrounding the antenna is divided into three regions. One is radiating far field, radiating near field, and reactive near field, where the field is inductive here, where the field is radiating here, but here the radiation is depends on angular distribution. Angular distribution of field depends on distance, but here it is independent of distance. Next question. A transmission line of 2 watt of power is feeding 2 watt of power to horn antenna having a gain 10 dB. Then total power radiated by the horn antenna into free space given power gain is 10 dB. 10 log of gain base 10 is 10. Now its value, the gain is also 10, and power input is 2 watt. Next, power output. So we know that gain is output by input. So from this formula, power output is gain into power input. So gain is 10, power input is 2 watt. So the answer is 20 watt. The output power is 20 watt. Here efficiency is not mentioned. So efficiency is treated as 1, the ideal horn antenna. Next question. The design of optimum equiripple linear phase FIR filter uses Chebyshev approximation. So the filter design method described in the design of optimum equiripple linear phase finite impulse response filter uses Chebyshev approximation. Chebyshev approximation. This method is also known as min-max criterion. Minimizes the maximum weighted approximation error. So that is min-max criterion. Next question. Which mode of propagation is adapted in high frequency antennas? So ionospheric propagation or skywave propagation. In this mode of propagation, ionosphere reflects the signal back to earth. It is adapted in high frequency antennas. Next question. The bandwidth of the channel used in offset is called instantaneous bandwidth. So this terms instantaneous bandwidth, hopping bandwidth, the total hopping bandwidth, it is related to frequency hopping spread spectrum system. So this is related to frequency hopping FHSS, frequency hopping spread spectrum. Again, this frequency hopping spread spectrum is of two types. One is fast frequency hopping spread spectrum and slow frequency hopping spread spectrum. One is fast. Okay. The bandwidth of the channel used in a offset is called instantaneous bandwidth. Next, the bandwidth over which hopping occurs is total hopping bandwidth. So offset means the total number of frequencies over which hopping occurs in FHSS. Next, hop time or hop duration or hopping period. Next is 3 dB bandwidth, the range of frequencies over which the power is greater than or equal to half of its maximum power, or the signal voltage is greater than or equal to 1 by root 2 times of maximum voltage is 3 dB bandwidth. The correct answer is instantaneous bandwidth. Next question. Dash of TDMA is a measure of percentage of transmitted data that contains information as opposed to providing overhead in for the access scheme. So it is efficiency. The efficiency of TDMA, time division multiple access, is measured by percentage of transmitted data that contains information. So data with respect to overhead, that is efficiency, TDMA efficiency, or simply frame efficiency. The number of total data bits transmitted to total bits. So total bits contains data bits as well as frame bits. So correct option is efficiency. Next question. If the length of intrinsic region of an impact diode is 4 micrometer and the carrier drift velocity are 10 power 7 centimeters per second, then the nominal frequency of the diode is. So resonant frequency or nominal frequency of impact diode is given as Vd by 2L, where Vd is a carrier drift velocity and L is drift region length. So from this carrier drift velocity, it is given as 10 power 7 centimeters per second, that is 10 power 5 meters per second, and drift region length is 4 micrometer, 4 into 10 power minus 6 meters. Now nominal frequency F is drift velocity 10 power 5 and drift length 4 into 10 power 6, 10 power 11 by 4, 100 by 4 into 10 power 9. So that is 25 kilohertz. So correct option is B. Sorry. 2L, 2 times of 4, it is 2L. 2 into 100 by 8. 100 by 8 is 12.5. 12.5 kilohertz. Correct option is A. Next question. Forward voltage that can be applied to SCR after gate recovery time. So forward voltage cannot be applied to SCR after anode current falls to 0. If anode current falls to 0, then we should not apply forward voltage because of presence of carriers. Forward voltage cannot apply to SCR after its anode voltage reduces to 0. This is also wrong. Forward voltage can be applied to SCR after its gate recovery time. SCR can be turned on after its gate recovery time, and then forward voltage is applied to SCR. Correct option is B. Next question. Peak inverse rating of triac. Triac means triode AC switch. The peak inverse rating of peak inverse voltage or peak reverse voltage of triac is lower than that of thyristor because triacs have lower ratings than thyristors. The correct option is C. Peak inverse rating of triac is inferior, lower, and very much less than that of thyristor. Inferior and very much less than that of thyristor. It is not same as that of transistor, not greater than that of transistor, it is less than. Load voltage of a chopper may be controlled by varying duty cycle. So chopper load voltage can be controlled by varying the duty cycle. So duty cycle means on time duration to total time duration, that is on time duration plus off time duration. And this duty cycle may vary from 0 to 1. Duty cycle is 0, so that means on time duration is 0. To complete duration is T off. The chopper is never switched on. So on time is 0 means chopper is never switched on, and duty cycle is 1. So 1 means off cycle is 0, it is always switched on. The load voltage of chopper can be controlled by varying the duty cycle. It varies from 0 to 1. Next question. A single phase full bridge inverter can operate in a load commutation mode in case if load consists of RLC underdamped. A single phase inverter can operate in load commutation mode when load consists of RLC underdamped. That is, load commutation does not occur due to overdamped system, so forced commutation is required. Single phase inverter is a type of inverter that converts DC voltage source into a single phase AC output voltage at a desired voltage and frequency. It is used to generate AC output waveform, converting DC input to AC output through the process of switching. And this is a definition for a single phase inverter. And this load commutation mode, it is used when our system is under damped. Next question. Dash is used in growing NPN heterojunction structures. So that is epitaxy. So epitaxy, epis means upon, taxis means arrange. This epitaxial growth refers to the process of growing crystalline layer on a substrate. Epitaxy is a term applied to a process used to grow thin crystalline layers on a crystal substrate, or method of growing crystalline layers on a substrate in a well-defined orientation. Different methods of epitaxial growth are molecular beam epitaxy, chemical vapor deposition, liquid phase epitaxy, and pulsed laser epitaxy, solid phase epitaxy. In the question, it has given liquid phase epitaxis for growing NPN heterojunction. So growing means epitaxy, and different methods are as per the options: liquid phase epitaxy. Again, this epitaxy is of two types: heteroepitaxy and homoepitaxy, homo or autoepitaxy. So correct option is D. The diode which emits light of single wavelength is. So in the question, so these LEDs and laser emit light. The tunnel diode and photodiode doesn't emit any light. These two emit light, but LED, it is a light emitting diode. It emits incoherent and divergent light, whereas lasers emit coherent and unidirectional light. So monochromatic means single wavelength light. So lasers emit monochromatic light. So correct option is C. Let us see the differences between laser and LED. LED is a light emitting diode. Laser stands for light amplification by stimulated emission of radiation. LED works on the principle of electroluminescence. Laser is based on the principle of stimulated emission. And the output of LED is polychromatic light. The output from laser is monochromatic light. Monochromatic and coherent. So monochromatic coherent light source. So the efficiency is also high. Narrow output spectrum, response time is fast and less distortion and dispersion in laser. Response time is slow, more distortion and dispersion in LED. Broad spectrum in LED, narrow spectrum in laser. Monochromatic coherent light source is laser, whereas non-coherent polychromatic light source is LED. The correct option is C. Next question. Which material in CRT glows high energetic electron strikes on the screen? So that is PASPER. This silicon and germanium, it doesn't glow, whereas PASPER will glow. When electron beam hits a PASPER screen, it emits light because PASPER converts the electron's beam energy into light. So this process is called fluorescence. Property of certain chemicals that allows them to emit light or to give visible light after absorbing radiation, which is not normally visible. So we cannot see the electrons. When electrons hit the phosphorus screen, it emits light. So this method is called fluorescence. So it is invisible and it will generate when this invisible radiation hits the phosphor material or certain materials. These materials will emit light. So it is visible. So converting invisible radiation to visible radiation. That is fluorescence. And aquadog is a conductive graphite coating used in cathode ray oscilloscope to collect the secondary emission electrons. So the purpose of aquadog is to collect secondary emitted electrons. So this bombarding of electrons after striking the screen release secondary electrons, and these secondary electrons are collected by aquadog. So correct option is D. Next question. If a multimeter has sensitivity of 500 ohm per volt and reads 50 full scale voltage, given full scale voltage VFS is 50 and sensitivity is 500 ohm per watt. So sensitivity is 1 by full scale deflection, that is resistance by full scale voltage. Reciprocal of full scale deflection current is sensitivity. So sensitivity is ability to detect small changes in a measurement. It is a measure of multimeter internal resistance. Sensitivity is a measure of multimeter internal resistance or its ability to detect the small changes in the measurement. Sensitivity is measured in ohm per volt or kilo ohm per volt. Higher the sensitivity means the meter can detect small changes in the voltage. So generally the meter should have high sensitivity. So from this resistance R is sensitivity into full scale deflection voltage. So sensitivity is 500 ohm per volt into full scale voltage, that is 50 volts. 500 into 50, that is 25k kilo ohms. It is the internal resistance of the meter used. So correct option is B. Next question. The use of SMPS. Question 95. LEDs. LEDs operate in the frequency range from 30 to 60 Hz. So LCDs, liquid crystal display, operates in the frequency range of 30 to 60 Hz, and the operating voltage is 3 volts to 15 volts RMS voltage. These LCDs provide thinner display as compared to cathode ray tube. LCD is a flat panel display technology mainly used in TV, computer monitors, and mobile phones, etc. Next, some more points related to LCD. The LCDs become commercially available from late 1960s and are based on light scattering effect known as dynamic scattering mode. So the principle of operation of LCD is light scattering effect. An electric field can change the orientation of molecules in a layer of liquid crystal and thus affects the optical properties. Such process is termed as electro-optical effect and forms a basis for LCDs. For LCD, the change in optical properties result from orienting the molecular axis either along or perpendicular to the applied electric field. This preferred direction is being determined by the details of molecules chemical structure. Okay. So LCD operating frequency range is from 30 to 60. Next question. The use of SMPS is normally limited to power levels around 100 watts. Switched mode power supply or switched power supply is usage is normally limited to power levels and usually around 100 watt. Next, see, these are the advantages of SMPS: high efficiency, lightweight, reduced harmonic feedback, isolation from the main supply, protection against excessive output voltage, possibility of conversion of unregulated input, generation of low medium voltage supplies are easy. These are the advantages, and the disadvantage is because it operates by switching at high frequency, noise may be troublesome. Next, switching regulator is also limited to transient response by the switching frequency and is usually considered slower than linear regulators. Switching regulator is more complex than linear type. However, it is often substitution for electrical complexity for thermal and mechanical complexity of high power regulators through RF interface can be a problem for SMPS, and it is properly unless it is properly shielded. So because of above these four reasons, four disadvantages, it is usually limited to power levels around 100 watts. So correct option is B. Next question. Next, the rate of silicon controlled the rate effect in silicon controlled switch SCS is caused by. So this is a symbol for silicon controlled switch SCS. Equivalent diagram is given. It consists of anode and anode gate and cathode gate. It consists of two gates, anode gate and cathode gate, and two terminals, anode and cathode. Now this silicon controlled switch gets switched on accidentally if anode voltage gets applied suddenly, known as rate effect. So definition of rate effect is SCS get switched on accidentally if anode gate voltage is applied suddenly, then it is rate effect, which is caused by inter-electrode capacitance between the electrodes G1 and G2. Between G1 and G2, also known as inter-electrode capacitance between G1 and G2, also known as transition capacitance. This transition capacitance is responsible for gate effect. So that is D. The transition capacitance between the gates G1 and G2, that is between anode gate and cathode gate, is responsible for rate effect. So some more points related to SES is this silicon controlled switch is a unidirectional 4-layer 3-junction PN silicon device with 4 electrodes, namely cathode gate, anode gate. Next question. Choose the correct statement. IGBT have lower gate driven requirements. IGBT have lower switching losses compared to BJT. So it is not higher, it is lower. Option A is wrong. IGBT have secondary breakdown problems. Secondary breakdown phenomena where current concentration in a small area of a device leads to localized heating and subsequent failure. BJTs are prone to secondary breakdown, whereas IGBTs are not. So IGBT doesn't have secondary breakdown. The lower switching losses compared to BJT because IGBT have MOSFET at the input stage, which provides voltage input control and reduces the switching losses associated with the BJT. Next, IGBTs are current control devices. No, IGBTs are voltage control devices, whereas IGBT have lower gate driven requirements. So option C is correct. So IGBTs are voltage control device, BJT is a current control device, FET is a current voltage control device. IGBT have significantly lower gate driven compared to BJT. BJT needs continuous base current to remain in the on state because because BJT needs continuous base current to remain in the on state, whereas IGBTs are voltage control devices. Once the gate voltage reaches the threshold level, IGBT remains in on state until voltage is removed. So correct option is C. IGBTs have lower switching losses. There is no secondary. The secondary breakdown problems are very less in IGBT, and IGBTs are voltage control devices. IGBTs have low gate driven requirements. Next question. The photovoltaic devices in the form of thin films, it is thin films which absorb and convert the sunlight into electricity is correct option is A, cadmium telluride. So CDTE is a photovoltaic device in the form of thin films which are used to absorb and convert sunlight into energy. CDTE, CIGS are two main types of photovoltaic semiconductors. CIGS is copper indium gallium diselenide. Thin film photovoltaic cells are made up of thin layers of PV material, conductive sheet, and protective layer. So PV material deposited on a substrate like glass, plastic, or metal is CDTE is one PV material. CIGS copper indium gallium diselenide, it is one more PV material used in the manufacture of thin film photovoltaic cells, and amorphous thin film silicon, AI silicon, or TFSI, thin film silicon. So correct option is CDTE. Next question. A light dependent resistor is basically a variable resistor. So light dependent resistor is also called photoresistor or light activated resistor. The principle of operation is photoresistive effect or photoconductive effect. Resistance changes according to the intensity of light. That is, if light intensity increases, resistance decreases, and vice versa. The materials used in the manufacturing of light dependent resistor or photoresistor or light activated resistor are cadmium selenide or SE, SE. These are the two different materials selenium used for manufacturing photoresistors. Therefore, correct answer is D. Light dependent resistor is basically a variable resistor. So the characteristics of LER, LDR, light dependent resistor are drawn below. These are the characteristics of light dependent resistor, where x-axis is intensity of light and y-axis is resistance. As intensity of light increases, resistance decreases. So these are the complete solutions for Kerala PSC 2021 question paper for lecturers in electronics engineering. Thank you.